Okay, welcome everybody to online learning. In 12.1a, we're going to learn about right triangle trigonometry. So you've probably learned this before as SOHCAHTOA. So if you take one of the acute angles in a right triangle, the sine of that angle, and we'll call this angle theta, the sine of that angle theta is going to equal the ratio of the opposite side to the hypotenuse. So the sine of that angle equals the opposite length divided by the length of the hypotenuse. The cosine of that angle is going to equal the length of the adjacent side divided by the length of the hypotenuse. And the tangent of that angle is going to equal the length of the opposite side divided by the length of the adjacent side. And all three of these also have reciprocals. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So this one's easy to remember. Tangent goes with cotangent, but the other two, people get confused. The same letters don't go together, so you have SC here and CS. So don't remember it as the S's go together because they don't. All right, you might want to recall some common Pythagorean triples. So the most common one is 3, 4, 5. Other common ones are 5, 12, 13, and 8, 15, 17. For number 1, we want to find the 6 trig functions of angle theta. So here's angle theta. We know that the hypotenuse is the long side, and it's always across from the right angle. So this is the hypotenuse. The opposite side is over here. This is opposite. It's the side across from the angle. And adjacent means it's touching the angle and it's not the hypotenuse. So this is a 12 and this is our adjacent side. So adjacent again is the side that touches the angle and is not the hypotenuse. Right, we start with sine of theta, that is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And in the future, you'll need to understand that tangent is also sine divided by cosine. All right, let's also find the reciprocals. So the reciprocal of sine is cosecant. And we just flip the fraction we got earlier upside down. Reciprocal of cosine is secant. The reciprocal of tangent is cotangent. All right, for number 2, that is the Pythagorean triple 3, 4, 5 with everything multiplied by 4. So 3 times 4 is 12, 4 times 4 is 16, and then the hypotenuse is 5 times 4, which is 20. We know this is our hypotenuse. This is opposite because it doesn't touch the angle theta. And then adjacent touches it, but is not the hypotenuse. Okay, SOHCAHTOA, opposite. You could actually reduce it now. If you reduce it now, you don't have to reduce it later. So if I divide this by 4, I get 3. Divide that by 4, I get 4. And divide that by 4, I get 5. So if you reduce it before, then you don't have to reduce 6 fractions. You could just reduce it once. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And I think the faster way to do tangent is always just to take the numerator here and divide by the numerator there. All right, the reciprocals. You have cosecant. Secant theta is 5 over 3, and cotangent theta is 3 over 4. Right, on number 3, we have an 8, 15, 17 triangle. Right, so this is opposite because it doesn't touch angle theta. This is clearly the hypotenuse up here. It's across from the right angle, leaving this one to be adjacent. So sine theta, opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta, you can just take the two numerators that you just had and divide them. Cosecant theta is the reciprocal of sine theta. Secant theta is the reciprocal of cosine. Cotangent theta, take the reciprocal of tangent. I find these ones without a picture to be easier because you only have to find one ratio instead of all 6. So draw a right triangle, any right triangle you want. Put A on one of the acute angles. So don't put it on the right angle. Put it on either of the acute angles. I'll just put it down here. We know that tangent A equals 7 over 12. Tangent is opposite over adjacent. So wherever you chose to put angle A on the opposite side, you have to put a 7. On the adjacent side, you have to put 12. Now do the Pythagorean theorem. Since this is not a Pythagorean triple, do the Pythagorean theorem to find the hypotenuse. So 7 squared plus 12 squared equals, we'll just call it c squared. This is 49 plus 144. So it looks like c has to be radical 193. And now we could answer the question. So they gave us tan A, and now they want to know what cosine A is. So from angle A, we do cosine, which is adjacent over hypotenuse. So that's going to be 12 over radical 193. You are not allowed to leave a radical on the bottom. So we multiply top and bottom by radical 193. Cosine A equals 12 radical 193 over 193. Okay, so again, draw a right triangle however you want. I'll draw this one a little differently. Put angle A on either of the acute angles. They give us cosine of A equals 1/2. Cosine is adjacent over hypotenuse. So on the adjacent side, I'm going to put a 1. On the hypotenuse, I'm going to put a 2. Doing the Pythagorean theorem in my head, this has to be radical 3. 1 squared plus rad 3 squared does equal 2 squared. All right, so then they want to know tangent of A. So from A, we go opposite divided by the adjacent side, which is 1. So that's just rad 3. All right, we draw a right triangle. Angle B goes on one of the acute angles. Sine B is 3/8, so sine is opposite over hypotenuse. So we're going to put 8 on the hypotenuse and 3 opposite of our angle B. Doing the Pythagorean theorem, this has to be 64 minus 9, and then take the square root. So this is radical 55. Right, we want tangent of B. So from angle B, you want to do opposite over adjacent. Opposite, we have 3. Adjacent, we have radical 55. Multiply, because you're not allowed to leave a radical on the bottom. So tangent B equals 3 radical 55 over 55. Okay, recall from geometry that special right triangles have side lengths that follow a certain ratio. So for a 30, 60, 90 triangle, the sides follow the ratio 1, rad 3, and 2. And you could multiply these by any number. So in the diagram, they multiply all of these by x. So they have 1 times x, radical 3 times x, and 2 times x. Remember that 2 is bigger than rad 3, so 2 is always the hypotenuse. 45, 45, 90 triangles have side lengths that are in the ratio 1, 1, radical 2. And you can multiply these ratios by any positive number. Okay, so for number 7, we need to find side lengths. We're given that the short side is 8, and I know this is the short side because the shortest side is always across from the smallest angle. So 8 is across from 30, so it has to be the short side. The 60-degree angle is obviously here because all angles have to add up to 180 in a triangle. So the long leg is the short side multiplied by radical 3, and the hypotenuse is the length of the short leg times 2. So that's the ratio 1, rad 3, 2, with everything multiplied by 8. Right, on number 8, we have another 30, 60, 90 triangle. This is 30 degrees down here. They give us the hypotenuse, so we know that the short side has to be 5. And then the long leg, so a right triangle has 2 legs, a short leg, a long leg, and then the third side is just the hypotenuse. So the long leg is the short leg multiplied by rad 3. All right, we have one more 30, 60, 90 triangle. They give us the long leg this time. So these are the most challenging ones. We know that the short leg is going to be this number divided by rad 3. So if I take 9 and divide by rad 3, have to rationalize that. So rationalizing, if I multiply the top by and the bottom by rad 3, then I could reduce it. So this is 3 radical 3. So the short leg is 3 radical 3. If you multiply that by radical 3, you get the long leg, which is 9. Now if you double the short leg, you get the hypotenuse. So to go from short leg to long leg, you multiply by rad 3. To go from long leg to short leg, you divide by rad 3. Right, 45, 45, 90 triangles. The two legs are the same length. So these both have to be 8. Hypotenuse, you just multiply by radical 2. Right, so in a 45, 45, 90, you multiply by rad 2 to go from leg to hypotenuse. To go the other way around, you divide by rad 2, but then you have to rationalize. So multiply the top by rad 2, multiply the bottom by rad 2. The lengths of these legs are both 5 rad 2. All right, that's it for 12.1a. Stay safe, everyone.